Okay, first thing first, logistics. I would like the TA star survey for exam 2 time. And also, several people asked me to have a review sessions before the exam. And I will also let her survey a time. I'll do the review sessions, okay? And that way, but the review session, I probably will record it, but it's not mandatory for you to come. And just let you have time to ask questions about the exam. And just like exam 1, all the problems, okay, really are from the homework. But at the same time, I think you guys will agree with me, it's not fair, right? If I just copy paste whatever in the homework and change the number and said, okay, just plug and play. Because if you only plug and play the template I give you, I still feel like the old saying, the emperor has no clothes. You pretend you know something, but if you really know something, you should be able to manipulate it any way you like. Okay, so I would like to do that. And for the exam 1, your redo, I will ask the TA probably add another 30 points on top of our original 100 points. That way we should move everybody into the safe range, okay? But exam 2 will be like exam 1, the same things, that there will be probably certain problems with certain sequence. And because, people say, oh, why don't you just using Zoom to monitor everybody? Let's be honest. Even I have you turn the Zoom on, somebody email you something through another computer about the answer, I won't be able to know. And so adding random number type of tricks, I have a few more I can use. Just remember, I worked for an insurance company before. Detect the fraud is part of my jobs. So I will find another way to do that. And in exam 1, okay, several people feel like, well, the random number you asked to add is so small. Therefore, of course, no need to do it another set. Shouldn't have any influence on the outcome. And for those of you, how many of you feel that way? No need to do 2. Okay, show hands. Okay, so I'll give you a chance. Okay, so if you add a random number, okay, whatever the random number you have right now, it's 100 range and then a tiny one, right? Times 2, times 3, times 4, times 10, keep adding it. So sooner or later, the random number will be so big that will have an impact on your ANOVA table, right? So for those of you who said that, well, it's negligible, I don't need to show that, I'll say that then show me where's the turning point. If you can show me, you can figure out that turning point. You can write an algorithm or Excel macro to show that, then at least I know you can do it. Otherwise, don't you think legally, even in the court, beyond reasonable doubt, you cannot just say that, well, you look at the number, it's so small. It shouldn't be influencing that. The jury might buy that, but I won't. I need you to use the sum of square to show that, it's not changing the sum of square compositions. It's not changing the composition. It's not changing the composition. And then suddenly you cross the line from p-value less than 0.05 to p-value beyond 0.05. If you can do that, then you are defending your analysis by number, not just I say so. Okay, if I say so can be good enough for any legal or in any technological argument in future product design, then no, you don't need this class because you say so, it counts, right? Yeah, so I need you guys to prove it, okay? I don't want you to just throw me the number. Okay, one more. This one is from the last homework 2, okay? Then I'm just gonna do it in a simple way to tell you how to build a cube, because people feel like they can build two-way cube. Simple one cube, but when you have two, it's getting hard. So let's just say that I have originally ABC, 3-factor. So I can repeat that 1 block, 2 block, right? So I can start from, let's just say -1. Usually I start from -1, +1, and I'll have a bunch of them, right? And then, sure, and this will be -1. Control C. Control V. And +1. Control C. Control V. And then in the middle, Control C. Control V. So this is a data point. And then how you turn this, so I just have some random number here. And control, okay, no need to do that. It's just, okay, so nobody should have any problem to put this A number into a cube, right? Agree? Everybody can put a number into a cube. Okay, and then of course, if I have repetitions, one more time. Everybody shouldn't have any problem to put 16 number into a cube. Just every corner, like the origin -1, the -1 position should have two number rather than one number, right? Everybody can do that, right? Agree? So here comes the hard part is, okay, what if I have D involved? So people, if I have D involved, you know for sure I can consider this is 1 cube for all D is negative. And then I can build another cube when all D is positive, right? So that is the way how you build a cube this way, okay? And actually, this is the Montgomery's notation. Guess what? There's another fancy way to draw the double cube. So people agree with me that you can have a negative cube and a positive cube, right? And now it will cover all the ABC, but when this cube is working out, okay, you will have what? A number here is repeatedly when D is small, or a number, A is positive. And so what looks ugly is really that we don't have the ability to draw beyond 3 dimensions. So young lady, challenge you a little bit. What if in the exam I give you A, B, C, D, E, 5-factor to ask you to draw a cube, and one more. I said, oh, I'm more interested in showing the cube for C, D, E. in a structure. How are you going to do that?
Is that where you like combine, like, if you're like looking at CDE, would you combine like A and B?
Aha. So you basically consider there's a AB negative block, AB positive block, AB negative positive block, and AB positive negative block. For each block, or the AB, so you basically you write AB kind of like as a number, but you show the cube. Inside the cube is the cube of CDE and CDE and CDE. And so you should have 4 CDE cube plot under those conditions. You follow me now?
Yes.
Then here is another things you can do. Okay, let me finish that. So we can move the number out. So suppose that I'm using BCD. Now I'll do this. Okay. What I'm trying to say is that at the end, let me find a place for that. Okay. Insert shape. Can I build a block like this, and then in this block, insert text. So I'll have A is low. A is low, B is low. On this corner. And then A is high, B is high. So can I first only take care of AB? That will be what? 4 corner. Each corner got, 16 number for AB, right? And then all those 16 number relate to what? On top of those number, you will have a CDE cube under those conditions. So in other words, how many cubes do you still have? You still have 4 cubes under AB, low, low, high, high conditions, okay? And this is the way I prefer to do it, okay? If you guys go read something else, they did it this way, okay? Looks fancy, but I think it's confusing. They will do this, have a cube, and they will put a cube inside a cube. You know how that means? Inside, D is negative. Outside, D is positive. In reality, let me ask you this. Putting the 2 cubes side by side and putting a cube inside another, does that change your Excel file layout? Not at all, right? It just looks fancy. But when you work in industry, sometimes the company you work for, they like to draw like that, the wow effect. For me, they are the same things, okay? And in the exam, probably we're not going to do this. The reason is, if I have to do this 4 factorial, then how many data points I'm going to have? It will be too many. So in order to have the exam cover enough stuff, but not, with a lot of number, I need to play a trick just like exam 1. Look like the same number, but it cover multiple concepts that way, okay? So to answer your questions, how to build a cube, you can do it side by side, 4 corner, or put it inside. But in reality, it's based on the foundation here, okay? Now, let me reorganize my lecture today. I'm going to cover all the homework example in chapter 8 first, which is the fractional factorial design. And when I finish all the fractional factorial design one, I'm going back to chapter 7. Because chapter 7, remember, I'm just doing repetition of 2 blocks, 3 blocks, different conditions. Then your next homework, this is what I have in mind, is I can give you a experimental design with 4 factorial. And then, for example, I can have 2 cubes, right? Or 3 cubes. And then I've just said that, you know what? First do the whole Normandy invasion. Assume that you're, General Eisenhower. You have all the manpower, all the resources of allies, so we can have a master invasions with all the resources. And you will find your p-value and everything. And then guess what's the next problem? I said that, hey, but your boss is cheap. He said, I'm not going to give you everything. I'm going to only give you half. So you use the left half or the right half, see if you can still get the answer. And if you cannot get the answer, can you do some trade-off and say that, okay, if I cannot have everything, and what should I get first? Okay? And, how many of you ever go to Golden Corral for a buffet, dinner buffet? Me too. Okay, so a lot of time, especially now holidays coming, they have holiday special, right? And sometimes say they have prawn or lobster, surf and turf, steaks, and then they have the regular soup, clam chowder, the salad and everything. So you pay say $25 for the buffet, okay? What are you gonna eat the first run? Salad, bread, the stuffing, or first run start from what? The big lobster, you can find one, lobster tail. The steaks you can find, start from the expensive stuff, right? Would you agree with me? And so, just keep that analogy in mind, is the homework we're gonna do is basically the same things. First, you have the appetite, you have the resources, you can eat whatever you want, or you can eat. Then you do a ANOVA with everything. But then what kind of ANOVA I would like you to do is, hey, let's be stingy. Let's be even stingier than we should. Now, you cannot have everything. And you need to pick and choose, right? And when you start doing your pick and choose, okay, show some deep thinking, okay? Because you already done the 4 factorial, there are things not so important, there are things quite important, there are things kind of somewhere in between, right? And psychologically, I want to do that. That's something else I would like to talk about. Some of you, let me see your screensaver. I know you have your boyfriend, your girlfriend, your loved one's picture there, right? And so here's the things. So say it's your anniversary, time to give a gift, okay? And, or, say even for your parents, okay? You want to send them a gift, okay? Something good, okay? So I say that you have a budget for $120. What would you like to give? One-time deal, 120, something really, really expensive. Or we can reverse it. Say it's your boyfriend or girlfriend try to, impress you. What do you prefer your boyfriend or girlfriend give you, the gift? One gift every month, $10, or no gift, one time, 120. Which one you prefer? Huh? Just one time, one big deal, and not a small one? Okay, now let me reverse the problems. Say you've done something terrible. You need to ask for forgiveness. Okay, you've done something terribly wrong. Okay, so would you like to separate the bad news into one, slices, and feed the bad news one slice at a time? Installment plan. I'll share a little bit something bad and then a little bit bad, or you want to give them the bad news in one shot. So no matter good news or bad news, you like to do it in one shot, huh? People talk about, especially right now, it's Christmas season, they talk about consumer or customer management. Generally speaking, bad news, people prefer hit me hard, one time, okay? But it's good news, they actually would like to have more than one surprise, or sometimes even incremental. First time $10, next time $20, next time $40, and finally give you a $50. And why is that? It's kind of like keep enticing you. There's something going on, okay? And so in experimental design, it's also the same things. It's are you looking for good things or looking for bad things? Okay? And then the second part is, would you guys agree with me? When we take the fraction, we can take everything's one shot, or we can, in other words, is that, are you going to focusing on the very, very bad stuff, or you would like to have a few more good enough going on? Then that is the intelligence I need you guys to play with when you do the pie chart or the bar chart on the first one, and you need to say that, what should I do? Okay? And just like when you go back to the Golden Corral Thanksgiving buffet, okay? Would you rather eat 2 or 3 runs of surf and turf? Or you still would like to say, okay, I surf enough, I turf enough, let me try, save some for cakes, save some for the chocolate smoothie, for something different. What will be your strategy? So this is something I would like you guys think about in the exam. Is this okay? Is have enough variety, or focus on 1 or 2 things only. There's a benefit between the 2 different considerations, and so this is kind of apply experimental design. Okay, people actually, this is not what I tell you. This is people actually done experimental design. They figure this out. Okay, you like ice cream? Do you go to Baskin Robbins or Ben & Jerry for composition? A lot of time, if you compare the Ben & Jerry or Baskin Robbins, their ice cream, the quality is good. Okay, but compare the quality with, say, some ice cream from New Hampshire, or somewhere in the farm, the mom and pop operation farm ice cream that we can get once we got outside the city. The farm ice cream usually is a lot better quality, a lot creamier and everything. But if you ask most of the kids, if they have the options, do you want to go to some farm for some really nice chocolate or vanilla ice cream versus Baskin Robbins. Guess what's the choice? Most of the kids want to go. Baskin Robbins or the farm? Huh? Baskin Robbins. But if you compare the taste, the cream, you know that the farm is better. So what is the reason people like to have variety or compositions? And you know what's the funny part? Is if you send the kid to take the kid to the Baskin Robbins, okay? If, say chocolate strawberry is the kid's favorite, guess he look around what he's gonna order at the end. Still the same thing. But people like to have the options. It's kind of like they have, they feel they have the power to have choice. But at the end, they usually stick with what they really want. So what does that got to do with system engineering? Here is the tricks. First, whenever you do projects, you want to submit a proposal, never write an essay long and, yada yada all the way. Always give your boss options. Oh, we can do experimental design this way. We can do experimental design this way. So you have several options. You always need to give your boss multiple choice, not essay. And once you give them the multiple choice, you'll have the variety of options for them to choose. And your boss probably at the end still pick the one cheap and get what he wants, but he likes to feel like he has power to choose. Just like the little boy or little girl, even they know the quality of the farm operation is better, but when they design the experiment, when they make the decision, even their decision at the end at a Baskin Robbins is pretty much the same thing. They like to go to Baskin Robbins because they feel they have the illusions that they have power over options. You guys follow me? Okay, so I would like you to think about this, okay? And because at the end, I'm not gonna just say that, hey, plug and play the spreadsheet. I need you to tell me if I can design this, I can cut it this way, I can cut it that way, what's the benefit? Okay? So first, let's go through the lecture notes. And again, I give you all the PowerPoint and the Excel file, and I'll go through them one by one. Okay, so you guys follow what I'm saying? Okay, so A1, okay, originally you have 16 trials, and then I'm using sometimes when I did my spreadsheet, I just don't want to cut them out. So when I play with it, you probably see some old homework or old example. Just small variation, the same things, okay? So here, the example is I have A, B, C, D, and then they, for homework, for example 1, they say that, oh, we're gonna use A, B, C, D to separate the two. So the step number 1 is you find your 16 observation, okay? And then you'll have your ABCD calculated. So ABCD will be +1, -1, and then you sort by ABCD. Once you sort by ABCD, half of them will be ABCD negative. Half of them will be ABCD positive. So far, so good? And then once you have the positive side and negative side, okay, and homework will be like this. Hey, you probably will do one is everything's. And then now I will say that, hey, do only the ABCD positive or only the ABCD negative. So now we'll pick the ABCD negative. So you have 8 observation, right? And then you need to remember this 8 observation is due to this kind of ACD. And so the problem a lot of people gonna face or got into trouble is they copy the A number and they dump it into a ABC not based on the sort. They just use negative, negative, positive, positive. Then that is not the right compositions, agree? Because this A number is based on what? Or ABCD negative or positive, right? So first thing first, people, you know how to, if I have a 16 trial, I'm only using half of them based on ABCD as my separations. Everybody show hands. You know how to get your positive side or your negative side. Next, when you copy your negative side, positive side, you know that you also need to copy the ABC value associated with that. Associated with the sort. Everybody know how to do that? Okay? And then after that, I probably will have a coding name. Oops, sorry. I will probably ask you, okay, if it's negative, 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 or this, what's the name of that? You know, AD, AC. You can figure that out easily. And after that, okay, you have the value, then you just multiply the negative positive contrast, and then you can build your contrast effect. One more. If, okay, the effect I'm interested in is A, okay, so I'm only interested in the A part. The alias is, there could be BCD, because A times ABCD equal to BCD. But could be BCD, could be A, but which one we're focusing on? The main effect, A. Could be B effect, but could be ACD three-way interactions on the other side, because the dividing factor is ABCD. So B times ABCD equal to ACD, and here are the things we're focusing on, and here are the effect to figure out those numbers using the regression approach. So computationally, this is no different from the 4 factorial design, except now we're just doing the estimate and the regressions and the sum of square using these equations to do it. So again, show hands. Everybody knows that the estimate and the regressions is the regression times 2 equal to the estimate. Everybody know that, the contrast? That this row, the relationship between the gray row and the pink row. Oh, I don't have pink. Yeah. And the pink row. The effects. One is the regression. One is the estimate. They should be positive, negative. So there's 2 steps. No matter you're doing for fractional, you know, halfway, 50% discount, or for experimental design. Those relationships never change. The computation never changed. Okay, so your last homework is or 4 factorial, no discount. This time is, I'm doing the discount. Okay, and you can estimate your sum of square. And of course, in the exam, I probably will have 1 or 2 and said, hey, I would like you to using the contrast approach to figure that out, or using the regression approach, x transpose x, x transpose y, to figure those parameters out, and just for you to double check. And no matter you're using the regression approach or you're using the contrast approach, you should get the same number. Okay, and everybody, wiggle your finger if you still have problem to get the contrast approach out and the x transpose x approach out. Okay, I'll promise you this. In the next exam, we're not going to do the 0, 1 regression. We will always just do -1. If we're going to be -1, +1, because I have this 3-way regression homework for you to worry about. Okay, so 2-way is always this way. Okay. Example A1. Please, they don't have Excel approach. Okay, Excel approach is my approach, but the answer how you do that is over here. Okay, so please read A1. And the other thing is that in your books, they always use this what they call the QQ plot or normality plot. And for you, you just do my smiley face or just find a way to show that which one's standing out. Even you just do a bubble sort, you will see that most of the sum of square are tiny. They'll be lumped together, and all the sum of square big will stand out. Those are the sum of square we use. Okay? Now, for A2, okay? Example A2, same things. Okay, and this time, rather than Senolita, see that? It's not A, B, C, D now, I have A, B, C, D, E. And then if I have A, B, C, D, E, and then this is not a bad thing to know, is that usually I'm using the largest interaction term as my dividing factor. So you separate them into the 2 set, and 32 becomes 16. Okay, and when you have the 16, you can find your computationally, nothing we're gonna do for 2-way factorial design, fractional factorial design, different from what you already learned in exam 1. Okay, and just like the 4 factorial design. So the really fun part is, hey, which one you're gonna use to build your upper part and your lower part. Okay, and then you have your estimate done, you have your sum of square done. The things that I would like you to think about is, you already have all the spreadsheet. You just plug and play. That's not what I consider you learn. The best way you can do is still read the textbooks, pretend you don't have my spreadsheet, start from scratch, step by step, to build it up. If you can do that, then you actually know the material. If you just say that, I don't know if I want to give extra deduction for, you know who I'm talking about. Someone, our exam problem is 5 by 5, right? Guess who turned in the answer just throw the 5x5 answer into a 4x4 Excel I give you, and then said, well, at least I got sum of the square. That's wrong. Okay? Yeah, just do it step by step. And this time, for sure, you have to, because the sum of square is getting very big, and it's biased. Okay, even on this one, people, you can easily tell, right? There are those single digit, and those are above 100, above 400. Those are the major effect, right? So for me, this is probably my lobster. This is my sirloin. This is my ribeye. And what is 189? Fried chicken. But after that, those are the cheap stuff. Okay, I need you to do it and identify the good stuff first. Okay. A3. Okay. A3. Where's A3? Okay. For A3, this time I actually done it, and I separate them into 2 blocks. And what is important for A3 is when they separate them into 2 blocks, they actually decided at the end, okay, to piece them back together. So in other words, remember, I can have first time using this to get it done, and this second time I can do it again. So now I do it twice. Okay, and somebody, I need to wake you up. I think several people is going to fall asleep. Okay, I can do A, B, C, D, 16 observation in one shot. Okay, but here obviously, rather than do A, B, C, D in one shot for 16 trial, I'm actually using A, B, C, D to separate them into 2 blocks. So I'm just doing this fractions of D equal to A, B, C once and twice. Okay? So in other words, is that rather than having the whole elephant, I say, I don't care about the whole elephant. I'm just going to look at the elephant from the sideway twice. See here? Confounded using A, B, C, D once. Confounded using A, B, C, D twice. Can anybody tell me why? Why rather than having all 16 trial, I'm doing, kind of like this fractional view twice? It'll
be the same.
Well, there will be a little different. And actually, we can take advantage of that difference for something else, okay? But first thing first, you guys follow me? Can I have an ABCD 4 factorial design using 16 observation, like a single trial experiment? Can I do that? But obviously, this guy said, no, I don't want you to do that. I want you to do, using ABCD twice, only, 8 trials twice. Why is that? The first thing first is that obviously he thinks that his focus is on A, B, C, D, A, B, B, C, those main effect and two-way interactions. So he thinks that he would rather have double check, triple check on those things he thinks is important. So in other words, there may be something else, but he feels like, those things I don't care. So he will say, okay, give me budget, do it once, give me budget, do it twice. Okay, so he has 2 blocks done as that way. Okay, So, and this is almost like, remember I just asked you guys, would you go for, more lobster, more steak, or you will balance your meal? Obviously, this guy feel like, well, I will focus on the stuff I would like. Okay? So in the exam, if I give you a problem like this, I'll give you the hint and said that, we can do it in one complete design. But your boss said that he would rather you spend the money with focus. He would rather you investigate something more thoroughly. Whenever I said something like that, more thoroughly, that means that probably something like this. Okay? Yes, and because you will see that, I probably will say that the total budget is $16,000, but run the fractional factorial design is $8,000. So obviously you can run a fractional factorial twice or run a fourth factorial once. Okay? But your boss says that he prefers something. Then you need to figure out, okay, should I, kowtow to my boss? And what will make him happy? Okay, so now you run a sum of square twice. Okay, so you can use the average of the two trial. Okay, first time 24, second time 19, and then you can use the first one and the second one. The average is the real regression for the things you care about. Okay, that will generate the things you care about. And what is important here is that, but since we run this twice, remember I said A for ABCD can also be the alias to evaluate the other side, the BCD, even though we ignore. Or B effect, the other side we ignore is ACD, ABD, things we ignore. Now, because we run the things we care twice, then we can say that, the differences between the two repetitions will give us the hint on the things we ignore. So now if you use the differences of the two trial, you can evaluate the things you ignore. Okay? So this is the sum of square computation, and in the example I give you, they call it a positive side and a negative side of the sum of square. Okay. Okay, and then you can evaluate it that way. Just do the sum of square computation that way. Finally, A4. Okay. Rather than have one ABCD EF, we can use ABC confounded based on ABC and BCD. Okay. So here I'm having ABCE. The first one I'm having ABCE confounded. Right? Using ABCE as my separation block. So E equal to ABC. Second one is BCD. So here, the first one is ABCE. The second one is BCDF. Okay? People, if I have this two to separate things, what else will be also considered as a confounding factor? Remember, using this guy times this guy. So what will be the other one get confounded? Howard. Based on this one, I know ABCE got confounded, right? Right? Positive ABCE, negative ABCE. This one, I know B, C, D, E got compounded. So now I have this 2 got used. What else got used? If I have A, B, C, E, and B, C, D, F got used. Multiply them. Square -1 equal to +1, -1 square equal to +1 square. So A still there. What about B? Is B still there? B is A, B, C, E. You have B upstairs, you have B downstairs, right? So B disappear. Okay. C disappear. D is there. E is there. F is there. Okay. So in other words, is that when you separate them equal to -1, +1 of this one and this one, you also separate them. You separate them based on A, B, C, E, based on B, C, D, F. You also separate them based on A, D, E, F. Okay? This I probably talked about it 2 weeks ago, and now this is a numerical example to show you that. Okay? And this is very important. Is what if in the exam I show you that I have one separate A, B, C, one separate C, D, F, one separate D, G, H. If I can have A, D, G, H. Okay? So if I said that I separate things based on A, B, C, based on C, D, F, based on A, D, G, H, I will ask you what else got separated. What are you going to do? A, B, C, and C, D, F. These 2, separated by A, B, C, separated by C, D, F. That means I also separated by A, B, D, F. Agree? A, B, D, F. Okay, separated by C, D, F, separated by A, D, G, H. That means I can separate them based on A, C, F, H. Agree?
A, C, F, G, H?
Let me do it this way. Say that again.
A, C, F, G, H, right?
Okay. I blame my bifocal. I have my A. I have my C. D disappear, right? Mm-hmm. F, G, H. Is that what you said?
Yep.
Okay. Okay. So if you separate it by this 3, you should also separate by this 2. That will be your answer. Right or wrong? Right or wrong, Senorita? I said, I can separate -1, +1 based on A, B, C. I can separate them based on C, D, F. I also separate them based on this. So when I separate them based on this 2, I need to separate them based on this 2. I separate based on this 2, I have to separate them based on this 2. So totally, those are the things I need to worry about, right or wrong. Wrong? Why is wrong?
Because I don't know, I guess what I'm looking at is what's the separated of the A, B, C, and C, D, F. And if you compare those like extra values to like the
So in other words, is that I could be separated also based on what? A, B, C against A, D, H, right?
Right.
So if I separated based on A, B, C, and A, D, H, that would be what? A disappear, B, D, C, G, H. Agree? Okay. Now, if I can separate by those 3 things, okay, what's the combo here? Look, A, B, D, F and B, D, G, H will become A, what? A, C, G, H. Agree?
There should be an F too.
Huh?
F?
A, C, F, G, H. Yeah. And guess what? A, C, F, G, H we already talked about. So This is just double check. And BDG, CGH, ACGH, if I separate them, that'll become A, B, D,
F.
F. Huh? No, I don't have F.
Yeah, there's an F and A, C, F, G, H.
Oh, F. And what else? That's it? And where is your ABDF? It's right there. So what I'm saying is that you can double check this by circling them back. However, don't do it in the exam. If you spend time in the exam, double check this, you should understand the mechanism and feel comfortable with it. Yeah. If you, in the exam, start saying, well, I've seen it in the books, I need to find it and read it, too late. Okay? And so now, if I'm block them into this, then I can build the regression, I can build the estimate. Oh, is this one I'm lazy? I did not do the X transpose X, but you guys can do it. Okay? And the things I did here is, rather than doing a chart like that, I just did a pie chart, and the top three. Okay, for sure, I would like to include the top three. Agree? The sum of square, the very very big one, and then the second one, and then the fourth and the fifth one maybe. Okay, but for me, this is the things. If you want to include the fourth one, you have to include the fifth one. Would you guys agree? Here, I just copy the sum of square and put it over here. Okay. What is important here is that you cannot just say that, oh, I want to keep this 5,001. Well, 5,001, you know for sure you cannot. If you dump that one, your boss gonna fire you, right? And then the 770, I know I want to keep, okay? And 564, I want to keep. So I can keep the first three, okay? Everybody agree? But if you say that here is the two tiny bump, the 115 and 95, you cannot include 115 or 95 alone because it's not going to be fair. If you want to include 115, you have to include 95. This is almost like at the end of the semester, the student will come in and bargain and say that, okay, you give those top three, A, I have no problem. But if you want to give him A, then I deserve A too. You guys can see that? So that's my way of showing you, this kind of like, okay, who you're gonna include and who you're not gonna include. There are some other plot. I will explain those plot in next lecture. So okay, it's not like I'm abandoning them. Okay, and finally, this time I'm having the fractional factorial design based on A6. The A6 is the one with tons and tons of extra factors. So it will be in your homework, but I will be very brave to put them in your exam because it's too many. The things I would like you to pay attention here is that all the observations, they take the log, okay? And using the log first before the value, before they put into the computation, and they did not explain well in the books or in the lecture notes. So please put it down. Usually we put log for the following three reasons. Okay? First, if you see your data was a very, very huge exponential increase, okay, then once you take log, the big number will coming down, so you can linearize your data set. Okay, so log, whenever you see a dramatic increase of the magnitude, take log, you can linearize it. Put that down. Okay, the second things you can use that for is if you see your variations of your data points, seems like they vary a lot in certain category and vary a little in other category. In layman term is when we see the local commute at different subway station, if you see that one subway station got a lot of large variation of local commute, but the other subway station got very, very little variations, and of course we need to do something about it, but usually when you see large differences in the variations, you take log. Then you can standardize the variations. Okay, so far so good? The third reason we take log is, write it down, the log x dx equal to 1 over x, right? Write it down. Just write it down, d log x equal to d log x dx, any log take derivative equal to 1 over x. So rewrite that like a differential equation in dvq will be d log x, okay, equal to dx over x. Agree? Right? And what is dx over x? That means that whenever you see something, the rate of change, dx, is proportional to the magnitude x. So if dx over x is kind of like a, proportional, you will see the rate of change depends on your x. For example, driving is like this, right? The stopping distance variation, when you drive 10 miles an hour, very tiny variation. Drive 20 miles an hour, a little more variation. When you drive 100 miles an hour, you stop, you skid, you will have a lot of variation. So dx is proportional to the magnitude, then you'll take log. So the books just say, you need to take log. I'm saying there are 3 reasons. What are the 3? Linearization. The variation is category dependent. And the third one is whenever the rate of change is proportional to your magnitude, you take x. Okay? If you guys take my Bayesian class, I'll explain more there. But here, just let you understand that that's what we need to do. And once you take that, okay, and you can do your sum of square, okay, and this. And generally speaking, okay, remember we're doing linear regression, we're doing central station, subway station. If everything looks fine, don't bother with logs because it's hard to explain to people. But if that thing's just monkey, causing a lot of problems, then log is the way out. Okay? Okay, so now let's go back to 7. Okay? The previous set. Okay? I haven't make up my homework set yet because I think it takes you sometimes to go through all the example and material. Okay? But for 7, okay, I already give you the lecture notes and the Excel file before. So you just need to go through them one by one. So here, I'm having 3 blocks, right? Repeat the things 3 times. In the exam, what will be the problems? Hey, do it because you have a lot of money 3 times. And then I said, hey, you don't have enough money. You can only do it twice. So you can do 1 2 block, 2 3 block, or 1 3 blocks, and then can you still get the same answer? And so computationally, since you monkey around with the same number, it shouldn't be too hard. And then, of course, at the end, I said, your boss is really, really stingy. Only can run it once. What will happen? And can you still get the same answer? Most likely, the really, really strong effect, no matter you're doing 1 block, 2 block, or 3 blocks, you're going to see it. But there are certain things, gradually, it's kind of borderline. You don't have enough resolution, enough repetition, you're going to lose the picture. Then, please argue as a system engineer, do I really want to investigate that? Okay? And the example is like here. I give you the, well, let me just, okay. Oh, is it my time or not yet?
You got a little more than 5 minutes.
Okay. Then, okay, I run this 7.1, 7.2, okay, and the 7.3. You can tell nothing different from the computation. The things you need to worry about is that you will have the block if you have a lot of money, or you can repeat something again and again. So in the exam, I probably would do it this way. Is first let you have all the resources. You can repeat and do the same things. And then I will be the stingy boss and said, hey, you can only run half of it. You can only run 1 fraction of it. What are you going to get? And then, of course, there are so many different ways you can skin the cat, right? Or politically, well, can do the evil things. What is your rationale to do it in certain way? Okay, and some of those thinking is in the book. Okay, or the material I give you to think about. Okay. Okay, I think I finished all the 2-way factorial design. We're monkey around no more than 16 numbers, just like exam 1. But when we do that, what we really have in mind is, I don't want to just have 16 random number. I want to take advantage of those numbers to show the differences, the contrasts, the directions of improvement in the regressions. Okay? So if you cannot show me the directions, you cannot show me the contrast, then I don't want to waste my money and my time with it. That is the the spirit of 2-way factorial design. Okay? If I run something, it's always my question is, so what? Who cares? Do you get anything out of this? If you don't, then don't do that. Okay? How many of you ever been to a buffet place that you're already stuffy, and then you still go back for another run? You just feel like, may I pay $20? Yeah. But at the end, you also pay the price because you need tum-tum, right? So that is the arguments we need for so far the 2-way factorial design. At the end, show the differences and show why you gain something out of it. Okay. Wednesday I will get through the 3-way factorial design and.